Captain Schwartz has assembled a terrific group of government and industry experts to discuss ways to anticipate and prevent the possibility of fires starting in passengers' checked bags due to damaged or defective lithium batteries contained within them, an ongoing and serious safety concern. Scott?
Thank you, Mark. I'd first like to take the opportunity to thank Administrator Elliott and the Pipeline and Hazardous Materials Administration for collaborating with ALPA on the Check the Box campaign that was announced this morning. ALPA identified undeclared hazardous materials years ago as an important safety concern, and I think this work will significantly reduce the amount of undeclared hazardous materials in our system. The Check the Box campaign is targeting hazards resulting from unintentionally offered hazardous materials in cargo. These hazards are similar to those from some items in checked passenger baggage. In both cases, these hazardous materials are often not properly prepared for transport because the shipper is simply unaware that they are regulated. In fact, most types of hazardous materials are not allowed in passenger baggage, and the list of prohibited items includes many common household articles. Hazardous materials that are either undeclared in cargo shipments or checked in passenger baggage are unlikely to have been properly prepared for transport. That means that untrained shippers likely used improper packaging and handling procedures in their preparation, bypassing important safety provisions. Additionally, airlines will not be able to mitigate their hazards because the airline will not know the nature, quantity, and location of these hazardous materials on board their aircraft. Today, we will focus on the hazards from portable electronic devices, or PEDs, in checked baggage. This term applies to an ever-increasing variety of battery-powered conveniences, such as phones, computers, toys, cameras, power tools, and even smart luggage. Since some passengers travel with 5 or 10 devices, there can be more than 2,000 portable devices on a single commercial flight. And since most of these electronics are powered by lithium batteries that can initiate and sustain fires and chemical reactions that can overwhelm existing aircraft fire protection systems, we believe action must be taken to mitigate the hazards. Last summer, the International Civil Aviation Organization convened security, operations, airworthiness, and dangerous goods experts to discuss the safety implications of large numbers of portable electronic devices in checked baggage. Based on FAA tests demonstrating the possibility of losing an aircraft if a single lithium battery enters thermal runaway, and the increasing number of battery-related PED fires on passenger flights, the group recommended restricting certain PEDs from checked baggage. As a result, there were 2 proposals to ban or limit portable electronic devices in checked baggage at the ICAO Dangerous Goods panel last year. Although neither proposal was implemented, the ICAO Air Navigation Commission is sufficiently concerned to keep the issue on the agenda for several upcoming technical panels. It's clear that the status quo is not acceptable to many aviation safety experts. While existing regulations prohibit spare lithium batteries in checked baggage, it is only a recommendation for portable electronic devices, and there is no limit to the number of items passengers may check. Many airlines, however, including Alaska, voluntarily implement restrictions that exceed regulatory requirements. So how can we mitigate these risks? Banning all PEDs from checked baggage is a very simple solution. And simplicity is important when the public is the regulatory target. On the other hand, a limited ban targeting only more dangerous devices would give travelers greater flexibility while focusing on the real safety issues. But a limited ban would also introduce regulatory complexity and be much more difficult to implement. It might, however, also provide incentives for electronics manufacturers to develop safer devices while simplifying passenger travel preparations. If we only regulate high-risk portable electronic devices, can airlines be expected to train and equip their staff to differentiate those items that are allowed from those that are banned? Gate agents and check-in staff already have difficulty deciding in real time whether certain items are allowed on aircraft because marks and labeling are often inadequate. A PED restriction of any kind in checked baggage can complicate passenger travel preparation. How is a passenger to realistically know what kind of aircraft that will be used on a particular flight? Large wide-body aircraft usually have large overhead bins, while small regional aircraft require almost all baggage to be checked, very often at the gate. Passengers connecting from large to small aircraft, from one airline partner to another, or from one carrier to an unaffiliated airline, may have to contend with a series of confusing PED rules. So what can be done short of a ban? Is it possible to sufficiently reduce the hazard by educating passengers to discourage them from checking their PEDs and properly securing those that they do check? Do we need a PED ban if risk can be mitigated by placing checked baggage in fire-resistant containers or separating it from mail or cargo holds, from mail and cargo in the cargo holds? For bulk-loaded aircraft, these may not be options. These questions and others will be discussed today by our panel. We're very lucky to have 4 distinguished guests that are involved in PED risk mitigation. Their collective expertise and experience spans more than 100 years of aviation safety work. We will start with a discussion of testing that has illustrated some of the hazards, continue with a description of the regulatory landscape, and then hear about some of the policy implementation challenges airlines might face, and finish with a summary of the very limited options that flight crews have in responding to a cargo fire. Our first guest is Richard Hill, the FAA's Fire Safety Program Manager, and he is responsible for conducting the experiments that demonstrated the hazards PEDs can pose in checked baggage. Go ahead.
Thank you, Scott. I'd like to give you a little rundown on testing that we have completed, and then go on to maybe the future. And as Scott alluded to, about a year and a half ago, in certain places in the world, the security people banned the carriage of laptops and tablets on board the aircraft in the cabin and recommended that passengers place them in the cargo hold. This stirred some thinking as to safety concerns with having so many devices in the cargo hold. And we looked at the regulations and how it would affect doing that. And lo and behold, that there were no regulations against having passenger PEDs in checked baggage. And in fact, most people thought that since it was legal and there had been testing done to transport laptops and iPads from the companies in boxes and cargo compartments in bulk, that why would it not be as safe having just 1 or 2 in a passenger bag? So we looked at the difference in the hazard and found that there's quite a bit of difference in the hazard of a newly shipped PED, iPad, laptop than that of a used one in a passenger bag. The fact that the higher the charge of the cell, the more hazard or risk there is that when a company ships a new device, they can ship the batteries at a lower state of charge. If you're putting your laptop into a bag, you're probably going to want to use it when you take it out. So most likely the charge in the battery is much higher, if not at 100%, which makes it more dangerous. Batteries have a tendency to fail because of overheating. Overheating can be accomplished in a packed bag where you have the laptop sandwiched between clothing and it's accidentally activated. You forget to turn it off or you have it in sleep mode. Another main reason that cells can discharge and go into thermal runaway is damage. And it's much easier to be damaged in a personal bag where you're not possibly packing it with enough insulation. The bag's being thrown around that's not marked properly. So there were a number of reasons we felt that it was more likely to have a fire from the batteries in the PEDs. Having said that, it was also mentioned that, well, the halon system that's in the cargo compartment should be able to suppress the fire that occurs from a single laptop. We know from experience in transport of large numbers of cells that as cells start to propagate, the halon can suppress the burning electrolyte that comes off of ions, but it can't stop the progression. And eventually, if you get a large heated surface or a spark, you can get an explosion of the gas that the halon can't protect against. So large transport of a number of cells, testing has shown to be of high risk. However, if you just have the one laptop, the number of cells in that laptop should not present a hazard, and the halon should be able to suppress the fire around it. Having said that, one of the main concerns that we had was in your bag, you may have other hazardous materials, and especially aerosol cans. Now, for some of you old timers, you remember back when ValueJet accident occurred, and it was an oxygen generator in the cargo compartment with a number of other canisters that had been activated, caused the fire, and in that case, it was a Class D compartment that did not have suppression in it, and the aircraft was lost. After that, the FAA looked at the hazards of oxygen generators and other hazardous materials, and specifically aerosol cans, and determined that the hazard was too great, and we put in regulations to ban the Class D cargo compartments and put suppression systems in all passenger cargo compartments to be able to handle specifically aerosol cans and the possible ignition and explosion of an aerosol can. All that testing was done with the types of fires that were likely to occur in the aircraft and the involvement of aerosol cans. Now we had a new type of fire that could occur from PEDs. So we ran tests to look at those types of fires and determined that they were different. They can burn hotter, they can ignite and have a much larger fire much quicker with less smoke originally. In our testing, we showed that you could have the case where a PED in the bag would ignite from a thermal runaway of a lithium cell. That fire could initiate an explosion in an aerosol can before the fire could be detected and the agent discharged and the agent get to a concentration within that compartment to suppress the aerosol can. If that happened, the overpressure could dislodge the liners in the compartment, making the suppression system not be able to suppress the fire that occurred after that. Therefore, it was determined that there was a greater hazard than would have been anticipated without the PED, just from a normal fire of electrical in nature or smoldering cloth or materials in a bag. So we recommended that airlines should look at their carriage of passenger PEDs in bags and do a safety risk assessment and determine if it could be done safely or not, or what mitigation they would have to take in order to allow their transport in a bag. In the future, halon will not be the agent used in cargo compartments. New agents will be developed, and we believe that testing needs to be done to determine its effect on lithium battery fires in general and the ability to carry portable electronic devices in bags. Thank you.
Thank you very much, Dick. That was an excellent explanation of how we got to where we are in our understanding of the dangers. Next up is Dwayne Fund, who is the International Program Coordinator for the Pipeline and Hazardous Materials Administration. That's the organization that writes the hazardous materials rules inside the United States. He's also been nominated by the United States for a seat on the ICAO Dangerous Goods Panel, and he is the chairman of the UN Subcommittee of Experts on the Transportation of Dangerous Goods. That is the group that designates materials as dangerous goods for transport and assigns the UN numbers that pilots should be aware or should see on their notices with respect to what dangerous goods are on board the aircraft. Dwayne, go ahead.
Well, thank you, Captain Schwartz, and good morning to all. It's a pleasure to be here. As Administrator Elliott had mentioned, PHMSA is the department's Hazardous Material Safety Administration, and we work very, very closely with the FAA to identify hazards in the aviation system as well as prioritize risk. And I know that this group has heard from in the past the hazards associated with lithium batteries in cargo. Much of that is based on the data that Mr. Hill just mentioned on the testing that demonstrates that the biggest hazards is if a battery goes into thermal runaway, it propagates to other batteries, that then escalates into an unmanageable event. And much of that then is factored around the density of the package and how many batteries then are co-located together. And that's why the regulations differentiate somewhat between packaged batteries for cargo and equipment, because the equipment is inherently, the batteries are separated due to the design of the equipment and somewhat isolated. Now, as just mentioned, what changed in that risk profile as relates to PEDs and checked baggage? Because we have long allowed certain dangerous goods to be allowed as passenger baggage. The basic rule is no hazardous materials, but there's a practical reality of consumer items that passengers will bring. And so we differentiate the risks with batteries and require those to be carried into the cabin so that if there is an event, they can be readily identified and dealt with, and then equipment is allowed to be in either carry-on or checked. But what changed is when certain countries either implemented or talked about implementing a prohibition of the equipment in the cabin, which would then place a significantly large number of this type of equipment into checked baggage. We really don't know exactly the amount, but we can, as Captain Schwartz had mentioned, we can imagine that just about every device nowadays is using lithium batteries. And that greatly changes the risk profile for checked baggage. So using the data that the FAA Technical Center presented and the effects of a battery that may go in a thermal event with other commonly transported consumer items like aerosols or some other flammable cosmetics, that could then cause an issue that would compromise the aircraft. And in the United States, the representatives to ICAO thought it prudent then to propose a ban as an immediate measure till we can address the issue. Now that wasn't at ICAO, there's 19 representative countries that participate actively in the Dangerous Goods Panel, and that really wasn't seen as a viable option for the majority. So that wasn't accepted. Now, subsequently, though, I think part of what that did is raise awareness within ICAO in the security panel as well, to sort of back off of that suggestion and not require the equipment to be removed from the cabin and placed in the checked baggage. The safety concerns were then brought forward, and that helped diminish in some respects the immediacy. But it still remains, and it's a concern that we are still looking at. And when we look at the risk mitigation measures now, they've all been built upon basically common consumer type sizes of batteries. And so there's, for rechargeables, there's a certain level that the industry would generally consider a laptop, the upper range of a laptop battery. And for metals, which are non-rechargeable, There's a limit that are used in other applications, like medical applications, that patient or passengers may want to carry for medical purposes. So, but we know right now that those regulations were built on really 1999 to early 2000 technology. And as we continue to work on initiatives to address the symptoms of the problem, for example, better packaging or prohibitions, we know that the technology is going to continue to move forward. It's going to change. It is already. The compositions, the chemistries, the sizes, the amount of energy that is being put into the increased energy put into the same footprint of a battery because of consumer performance demands is increasing. And so we're looking at is there a way to address this problem in the long run? So we can continue to put Band-Aids on and try to address things as we find out about them, hazards as we find out about them. But typically we'll be behind the curve. Regulatory development takes, unfortunately, longer than any of us would like. And so how do we get ahead? So one of the options under the United Nations, we have a United Nations group that deals with hazardous material safety. This core system of classification, testing to determine what kind of hazard a material, an article may have, packaging, hazard communication, all of that needs to be standard globally. And so that's what our UN subcommittee does. So one of the initiatives we're trying to do at the moment is rather than regulate consumer lithium batteries based on the chemistry, whether they're rechargeable or not rechargeable, the electrolyte, the size, as the technology is emerging very, very quickly, is there a test-based scheme that we can utilize? Can we through certain testing, determine whether a battery is going to be a low risk in a thermal event, a medium risk, or a high risk? And that's kind of how we do other dangerous goods, commodities like flammable liquids. And if we can do that, then we can tier our transportation requirements based on that level of low, medium, or high risk, and perhaps place more appropriate safety measures and be able to more readily identify, perhaps even in the system, those different tiers. And ultimately, the hope of many in our UN group, and certainly myself as the chairman, is that once we have a system like that in place, oftentimes that drives the industry to improvements in the safety system. Right now, much of their drive is the performance of the battery, because that's what consumers ask for. And if it's very prescriptive, which it is at the moment, then if they can drive performance but still maintain the chemistry and size limits, then it be allowed to be carried on an aircraft, then they'll continue to up the energy in order to improve performance. That just is the business model. So if we can instead provide incentives through this safety testing to perhaps put in some incentive to raise safety and then maximize or at least balance the safety and the performance of the battery, that's ultimately, we would hope, would be a solution to some of our concerns with the safety performance.
Thank you, Dwayne. One thing that stands out in what Dwayne just said to me is the importance of SMS and finding airline-specific solutions based on the airline's risk profile, because sometimes the regulations can't or won't address some of the safety issues. Which brings us to our next guest. Mike Tobin is the Dangerous Goods Manager for Alaska Airlines and is responsible for the development and implementation of their airline's dangerous goods policies and procedures. He's one of the people that has real responsibility. The decisions he makes in a real way affect passenger convenience. So his decisions affect millions of travelers and cargo shippers every year and how they're implemented on his airline. So Mike, go ahead.
Thank you, Captain Schwartz. So one of the concerns that we have with PED fires is that really not just limited to PEDs, but that we don't have some means of mitigation. So for example, fire containment covers and flame-resistant covers, you may have heard of them, especially if you're familiar with some of the wide-body all-cargo airlines that have them. They've invested millions of dollars on their own, done a great job with different solutions. But as of yet, nothing exists for the narrow-body operators, such as ourselves and many, many others. And we have to bulk load the operation. So we carry the baggage, mail, and cargo, COMAT, all together in the same compartments. As well as we have gate check bags that don't fit upstairs, they come down, or we have like a valet type service on our regional product. I've just been named to an Underwriter Laboratories standards body last week, we will be working on battery fire containment products, and I've been involved with the G27, SAE G27, as well as everybody up here and hundreds of others, it seems, for the last few years, as we work on that approach as well. On the left you see, and I use these pictures for the battery makers and the industry who aren't as familiar as most of the people in this room are with the operation, but we've got mail trays in the middle, DG coming out in the front, and bags come along on the right. In the center, we have a ramp person loading bags forward. We've got mail in the aft. And I've had people tell us, well, we maximize our bellies 100% for economic purposes. And we go, no, we cannot. We need to have separation at the top so that air can circulate, so that the smoke detection system works, so that the fire suppression system works. On the right-hand side is a Q400 showing the bag staffed, because we've been told, well, you can't worry about bag fires. They're not important in the statistics because we're only going to talk about cargo fires. And we go, yeah, there's no difference to us. They're all loaded in the same place. We also have other concerns too, and that's with the United States Mail, because they don't tell us about lithium batteries in the shipments, and there is no hazard communication on the outer packages. So, and just this weekend, so these come through, the two that you see are through, we're able to see them through kind of a translucent bag, but a lot of times the bags are opaque. This weekend, a cargo vendor of ours saw a UN 3480 primary lithium battery mark on a mail sack and refused it. It went back to the Postal Service, and luckily for us, he was on duty the next day when it came back with a new postal tag, and he rejected it again. We've sent the pictures to the Postal Service. This time we also notified FAA Hazmat. Technically, the Postal Service is not under 49 CFR, but we need help. They are interested in trying to keep track and work together intergovernmentally. But again, there's more unknown hazmat that we, besides what we know, what we assume is in baggage, we have to assume it's in mail. And Captain Schwartz mentioned that airlines can have more stringent policies, and we're one of them that does. I'm on the IATA Dangerous Goods Board, and we work with IATA to try and come up with best practices for airlines and make things more seamless, because we interline, we work with other airlines. Passengers go from one to another, typically, and we can do our own things. So this was a headline from earlier the year, actually December. We found out, and well, we knew, that ICAO was going to have policies implemented by the end of the year. But we said, no, this is a safety initiative. We want to do it right now. And so we did. A side effect of the policy is that 2 smart bag manufacturers have since gone out of business, but others are trying to take their place. And one of them was reaching out with us to help with the regulations, even wanting us to review so that they could advertise that we approve their product. And this is actually a quote from an email to us that said, we think it would be a good PR move to show that Alaska Airlines supports innovation instead of being seen as the bad guys that killed the other smart luggage brands. And, okay, I'm sorry, but I'd rather explain why something didn't get on a plane than why it did. And in fact, although I did not debate this company, but I have my emails from 2.5 years ago to one of those companies that went out of business, and why, in my opinion, their bag was actually a lithium battery and would not be allowed. So in my sense, in my mind, I feel, I'm sorry I told you, but that's the thing, and that's what you get sometimes when you're out there in the forefront, but again, I'd rather be accused of being safe than not. And smart bags have been an operational challenge to us. We have a few reports a week by ground and in-flight staff that have encountered them. We've had some delayed flights trying to rectify the problem. We've even had an air turnback. Customer realized after departure that, oh, wait a minute, my gate check bag had a lithium battery in there. I forgot to take it out. And out of abundance of caution, the crew decided to return. And this is an example here of how complicated it can be. Our agents in Kelowna noticed the USB port at the top, and the customer said, no, I don't think I have a smart bag. They looked at the top, nothing was there. They followed the wires into the bag, and the battery was deep inside its own zipper case. So these are some of the challenges, that our airline and every other passenger airline is going to face if they haven't already started to ban them, but they will by the end of the year when the ICAO ban comes into effect. So one thing we've done, or are looking at, is that we've got different groups. Our ticket counter agents, gate agents, ramp staff, in-flight, have all stopped smart bags. We've had different people come up with different ideas. Our Portland station came up with a tag idea. Now at Alaska Airlines, we do safety risk assessments for just about everything. Not just, we do an SRA, of course, we go to a new country. We get a new aircraft type. Yeah, we're going to do a bunch of SRAs for that. But even a new tag has an SRA, at least one. And you think, well, what's the safety aspects of a tag? Not probably with the tag, but what are are we introducing any hidden hazards in this? Are we introducing, some other ramifications? Could this impact somebody else that we hadn't thought of originally? So we'll do an SRA on this. We'll get other stakeholders involved, and then we'll go out and field test it and see how it works. Is this the best idea? We believe in continuous improvement and keep trying to make things better for the customers as well as our staff. And thank you very much.
Thank you, Mike. I was listening very carefully when you talked about air turnbacks and flight delays. And that, I think, goes to the complexity of the problem, the difficulty of having complex regulations. But again, it's a complex issue. And that's why we need to work very hard to try and get to the root of it. Finally, Mark Rogers is a captain for United Airlines and is a hazardous materials expert in his own right, having served on the dangerous goods panel at ICAO for more than 10 years. Captain Rogers has flown several types of aircraft at United, both domestically and worldwide. I think, having talked to him about the issue, I think the discussion will probably convince a lot of you of the appropriateness of the words in the title, anticipating and preventing, that we used in the title for this panel. So Mark, go ahead.
Thank you, Scott. So far we've heard about the PEDs in cargo compartments and in passenger bags, and if we ever do get to a point where we have a fire in them, Scott asked me to provide the flight crew's perspective about what happens then. Because in a lot of these international meetings that I go to in these different forums, you get the opinion that comes back, well, you fight the fire and then you can just land the airplane. And of course, we all know it's a little bit more complicated than that. So I wanted to start with just what all goes on once we do get the fire warning in the cockpit. And of course, two things have to happen essentially simultaneously. We have to both land the aircraft to divert the aircraft somewhere quickly, and we also have to fight the fire. And as an aside, it brings up what we talked about this morning. This would be one of the prime situations where having two pilots is very important in the cockpit. This would be a very difficult thing to do with a single pilot, because you do have one pilot who is assigned to follow the checklist and essentially discharge halon into the cargo compartment and comply with all the flight crew checklists associated with the fire in the cabin. And then the other pilot is focused on actually landing the aircraft as expeditiously as possible. But we know it's not that easy to land the aircraft expeditiously. You have to take into account a lot of different factors, including what the nearest suitable airport is, the weather at those airports, runway length, airport considerations, approach considerations. We have to coordinate with different departments within the airline to make sure we're making the right choice, including our dispatch and people on the ground, as well as in a passenger situation, coordinate essentially with the flight attendants for a possible evacuation and preparing the cabin. And as Scott mentioned, I've flown in a lot of different environments, and that's the case where you have an airport within a relatively near distance that you could land to. course, in the international operation, or even what I'm flying now with the 737 on the way to Hawaii, we don't have that all the time. And so you may even be looking at a possible ditching in certain cases like that. I think most of the pilots who've been in the industry for a long time are aware that the average time from the indication of a cargo fire to the loss of the aircraft is about 19 minutes. So we know that we have to put the aircraft on the ground as quickly as possible. And unfortunately, there are a lot of routes, as I just mentioned, that don't have any airports that would be within that amount of time frame, especially in ETOPS scenarios. We also have very little information about where the fire is coming from. We essentially only have the fire light and an indication of whether it's in a forward or aft compartment. If we know that we have dangerous goods on the aircraft, we don't know if that's potentially involved. All we know is that maybe it's in the same cargo compartment as where we're getting a fire indication. We also have no indication at all about the effectiveness of the suppression effects. So we discharge the bottle, and on the longer range aircraft, you'll get one bottle to go at immediately, and then later on a metered bottle. But we don't know whether that suppression effort is being effective or not. We have no trend indication, no temperature indications, nothing that would tell us whether it's actually working. And of course, the detectors are particulate detectors, basically, so that if you had a fire, you had any smoke in there, or even halon, you will probably continue to get the fire indication long after, even if it's suppressed, because of what all remains in the cargo compartment. And if the fire on especially the wide-body aircraft, where we have baggage that's containerized, if the fire is started in a container, it may be significantly later before that fire is ever detected, because the regulatory framework is that a fire is detected within 1 minute. But of course, that's not taking into account if the fire starts within the container, builds within the container, the smoke is within the container, and then when it does come out, it tends to sink. By the time that you get the detectors on the ceiling to activate, you could have a very involved fire in that container. We also have no fire suppression cooling ability for the cargo compartments. In the cabin, it's different. In the cabin, we can use liquids and waters and different things to cool the PEDs or the fires. But in the cargo compartment, the halon is good at suppressing the flames of the fire, but it does nothing to reduce the heat associated with it. And of course, the heat is one of the most important things with lithium battery fires and PED fires or any of these, because it's the heat transfer that causes thermal runaway in additional PEDs or additional batteries in the cargo compartment. And so you could have a case where you've suppressed the fire, but thermal runaway will continue because although the flames are suppressed, nothing is being done to dissipate the heat. And if that heat is sufficient enough, and you have, as you mentioned, a case of up to 2,000 batteries in the cargo compartment, you could have a situation where you're causing more batteries to go into thermal runaway just because of the heat being transferred by that first event. Of course, if every bag has a PED, the fire could then spread significantly through the cargo compartment because of that, even with halon. And as that thermal runaway continues, one of the things that Dick mentioned is that those batteries release gas. And even if you're suppressing the flames from the lithium batteries in the PEDs, they can still release gas that could build up and become an explosion hazard. That actually speaks to one of the things about our understanding over the last, I think I've been doing this almost 20 years, which makes me a newcomer for Dick, but I've worked with Mike and Dwayne since the start here too. So we've all been looking at this for a very long time. And at least from the pilot perspective, when we started, we had kind of a different understanding of where the risks were. We initially focused a lot on lithium metal batteries because the halon suppression systems don't have any effect on those batteries. And we thought that the lithium ion batteries represented a lesser hazard because halon was effective. But as we've gained more knowledge through testing that Dick has done and others, and we've learned a lot of different things about the ion batteries that indicate that they do present more of a risk than we initially thought. One of the things, some testing by UPS actually determined that this gas that we're talking about could build up and become localized and present an explosion hazard, and if that happens, you could dislodge the cargo panels in the compartment and lose the halon fire suppression effectiveness. So that's been a very big learning curve as we've come to understand where the hazards really are. And another one is what Dick mentioned in his presentation, the fact that especially in PEDs and passenger baggage, you could have the lithium batteries packed next to other household items, aerosols, different things that amplify the hazard that they present. So that's a very important thing. Certainly there's no protection against fires in passenger baggage. The G27 group that a couple of us have mentioned here is a group that is attempting to develop a packaging standard for lithium batteries being shipped as cargo, such that if a battery inside the package goes into a thermal runaway or has an event, then the event is contained within that package. So there's no fire that comes out, there's no excessive heat, there's no dangerous gases that come out of the package. But of course we have nothing like that for passenger baggage, and no training for the people who are preparing them. You know, we try to train our shippers to prevent against short circuits and different things to protect the batteries, but the passengers don't receive any of that. And when they pack their PEDs or they put their lithium batteries in the baggage, they don't necessarily take all the precautions that are necessary. So my point in bringing all of this up is just to emphasize what I think most of us all here know, is that by the time we get the fire warning, it may actually be too late. That we need to really focus on regulations and airline practices in place that prevent that fire from ever happening in the first place, because it's not as simple as just discharging halon and landing the airplane. The halon may not be as effective as we like to think, and landing the airplane may not be as easy as we'd like to see. Thank you.
Okay. Thanks a lot, Mark. That was very interesting. First, I'd like to mention that if you have any questions for the panelists, people in the room, feel free to approach the microphones. If you'd rather text the question, there should be a card on your table with a telephone number to text to. I think Mark's discussion, in a way, is chilling, because it demonstrates the lack of options we have once we realize as pilots that there's a problem. So I'd like to kick off the discussion by asking Dick Hill, are there any solutions on the horizon at the airplane level? And one of the issues is, even if they develop a solution today that works on lithium batteries, it may not help us, because it will not, an aircraft level solution, a redesign of a cargo compartment, will probably not encompass half the world's airplanes for 20 or 30 years. But in a more general case, are there fire compartment solutions that'll be more effective on some of the dangerous goods or lithium battery type fires in the works, or do we have to concentrate our efforts in other areas?
Well, I know of no universal fix. There are mitigation strategies for certain types of cargo compartments, as was mentioned by Mike, that some of the larger freight airlines, UPS and FedEx, have looked at developing fire-resistant containers and fire covers. There are fire suppression systems for freighters that have been developed. All of these systems provide some form of risk protection, but none of them provide an absolute protection against all lithium battery type fires. They just give you some added protection. So you have to look at how you're transporting, what your route system is. So there are things you can do to reduce the risk, but not to eliminate it. There is a big push to come up with replacements for halon for handheld extinguishers. There are new extinguishers going into planes right now with an agent called 2-BTP. So we need to look at the effectiveness of that agent as compared to halon for battery fires under different scenarios, and make sure that it's at least as effective, and hopefully maybe it'll even be a little more effective, and maybe change some of the procedures based on what we find for use of that extinguisher. And then there are new agents being proposed for cargo compartments. None of them have come to the area where they're able to be used in aircraft or certified in an aircraft yet, but as these new agents come in, we're going to have to look at their ability to protect against battery fires. And as Mark mentioned, the gas that comes off, the major problem with lithium-ion batteries is it produces a large percentage of hydrogen gas, and halon is not very effective preventing an explosion from hydrogen, you'd need a concentration of maybe 30%, where the requirement is 5% for a knockdown and 3% for long-term flight. That's a long ways from 30. These new agents, whether they're better or worse, no one knows, because no one knows what these agents are yet. But there's something that's going to have to be looked at.
Okay, so the people that are hoping for an aircraft-level panacea, it's going to be a long time before that's coming. Okay. That's not, I think, what a lot of us wanted to hear, but that's where we are. Mike, you talked about airlines and carriers doing things over and above the regulations. And I'd like you to tie in either some of the things you do or some of the things you're aware of that other airlines do. You don't have to mention your competition if you don't want to, or they're not even competition in some cases, because your route structure might be different than United's, for example. So you have different things you take into account when you do your risk assessment. Can you talk about some of those and some of the things that somebody that does long over water flights, for example, might might do? Again, typically you do long over water flights, but a lot of your route structure isn't.
No, yeah, I'm not sure what our percentage is, but we do, it's fairly significant actually how much of our flight network now is ETOPS to and from Hawaii, all the way from Alaska down to Southern California. So that is a factor now. That wasn't present, 10 some years ago. So that's right. As our reality changes, so does our hazards and risks, if you will, in terms of what we look at. So one thing we did was early in 2016, we equipped all of our aircraft with the battery containment bags where you can put flight attendants, an additional duty, of course, is they're firefighters, battery containment bags, so a hot overheating device can be put inside them. And we have one, a smaller bag in the flight deck for the tablets that the crews have, and then a larger bag, mid-cabin generally, for any kind of passenger gear. So far, the events we've had either happened too quick, something burned right through the backpack on the floor, and then it was put into the bag, or more often, customer's phone gets hot and they put it in there as a precaution and then deal with it. So we haven't had one actually explode in the bag yet, but that was one thing we did very early on when there weren't very many different products available, but that was just a commitment we did, all aircraft fleet-wide. A different thing that IATA did, we were realizing there was no limit for number of batteries that people can have in baggage, so we discussed about types of PEDs and things, and we came up with a limit of 15 smaller batteries in baggage and 20 spares, and again, generally for like hearing aid batteries for passengers doing large trips, just to give airlines guidance. We're not comfortable with unlimited, but so here's a line. If you don't like it, feel free to go lower. If your situation and your risk management says you've got a situation where you've got to go higher, okay, but we recommend this as some guidance. So we do different things like that.
Okay, thanks. I apologize for the error. I meant the distinction I think I was trying to make was between large and small airplanes, wide body versus narrow body, because they have some different considerations. I didn't mean to minimize your route structure in the overwater flying that you do. We have a text question that I think we'd like to go to next.
So this question is for Mr. Hill. You talked about the different new agents that are possibly coming down the road. What kind of timelines do you expect before these new agents capable of containing a lithium battery fire are approved and operational?
Okay, first, maybe there's a misconception. I don't think I said the new agents would be able to contain lithium battery fires. New agents have to meet a minimum performance standard. That minimum performance standard looks at a number of different requirements. It looks at Class A type fires. It looks at flammable liquid fires. It looks at exploding aerosol cans. At the present time, there's no requirement to look at its effectiveness against lithium or lithium-ion batteries. The requirement is it has to be as good as halon is. in suppressing fires, and halon isn't very good at suppressing a lithium battery fire. Timeframes, there are some proposed agents that are being looked at and going through the minimum performance standards. Probably realistically, they won't go on to newly built airplanes probably for 5 years and maybe longer.
Thanks, Dick. Dwayne, when I read through the regulations, whether they're for cargo or for carry-on baggage or checked baggage with passengers, they can get quite complex. And I can read them and study them and be involved in discussions on their development, and then 6 months later, it's just a jumbled mass of complexity. Do you think that has a major impact on the effectiveness of the regulations? Is there a way to simplify them? And again, can you also talk as a related question, harmonizing, again, we're talking about the passenger provisions more than the cargo provisions. Are the U.S. standards harmonized with the ICAO regulations, or is there still a difference? Are you aware of differences between the U.S. and the international standards for carry-on and checked baggage?
Sure. Well, I'll start with the complexity of the regulations. Certainly this is a complex problem because lithium-ion batteries have become really the portable power source of choice for the public. Production has grown from 3 billion cells to 7 billion cells in the last 10 years. Cells could be a single battery, or they could be built in to make a bigger battery. 330 million laptops and tablets were manufactured just last year. So they're into everything just about now, which greatly complicates things. And when we look at complexity, one person's simple regulation is another person's prescriptive, overly restrictive regulation. And one person's complex regulation is another person's performance risk-based regulation. So it's sort of trying to draw that balance. If we make risk-based decisions, how do we use the data to make sense and make it practical and make it usable from people? And it's different because our regulations initially were developed very much for industrial or commercial applications where you have people in that business, not necessarily for the general public in this case, where it's much more difficult. But some of the discussions, for example, we had in ICAO when we talked about full-out prohibition of passenger or having the equipment in a checked bag, is that, well, you look at things like hearing aids or other small medical devices or electric toothbrushes or razors or things that are common toiletry type items that a passenger may want to bring, and you try to tell them they can't do that when really the testing demonstrates that those aren't the battery sizes that we're overly concerned about, really. And so that's where the thresholds and the complexity comes in trying to draw distinctions. And we could try to do it. Certainly there was an attempt in the security area to say, well, anything larger than a cell phone. And that's kind of difficult because by the time we get the regulations in place, those sizes really don't mean a whole lot. And so, we put figures in and we try to, have the manufacturers mark them on the batteries themselves. But we do recognize and certainly try to continue to evolve the regulations in a much more simple approach. As it relates to harmonization between ICAO and the U.S. regulations, many of these things we do take and address at ICAO internationally because they're global. Trade and air transport's a global enterprise. And so we don't want different standards domestically than we do internationally. And so we may present some of these things internationally first and then work to bring them back. But they're two different processes. At the moment, what we typically do is try to amend our U.S. regulations on the same 2-year cycle that ICAO does and try to get out the notice of proposed rules making, in this case, for example, summer of this year, so that we can try to get a final rule out so it's effective 1 January when the ICAO provisions would be. That's our general process. If we get into something that we feel is going to be more of a significant nature in our business of Office of Management and Budget, we may have to pull that out and deal with it separately. Right now, as it stands, the passenger provisions are, I think there's only one that deals with a medical device for lithium metal. Authorization's a little higher with the operator's approval. Otherwise, we're harmonized. And if we follow our normal course of harmonization, we would hope to address that and have our regs harmonized by the time the ICAO measures come into place 1 January.
Okay, thanks. I apologize, I didn't see who was first. Okay, go ahead.
Hey, I'm Mark Henniger with Alaska Airlines. I work with Brian Moynihan. Every time we have something bad happen on the airplane, it's Brian and I usually making the calls and dealing with the after effects and doing some of the investigation work. Thanks for the great panel, Scott. And I also want to thank especially the panelists and Mike Tobin for coming all the way out from Seattle for Alaska Airlines. We appreciate that. One of the issues that we saw here 3 years ago, Alaska had a very high-profile diversion into Buffalo that created media attention because our flight attendants have been issued cell phones with attachments that took credit card information, and one of them kind of had a thermal runaway. It was kind of a little bit, we got lucky basically. The device was dropped on the floor, kind of a hot potato kind of thing, but it was managed to get under control. But the thing that terrified us from the safety side was the amount of resources that were used to contain one phone. It used 60% of all the available firefighting resources on the airplane to take care of that one little phone. And that would have been a 6-hour flight. Think if that had been on your, halfway out over the water. So my question to you is, has there been discussion, and it's the same problem down below as it is above deck. My question to you is, has there been any discussion of adding, not necessarily different, but additional firefighting resources? You're right, at Alaska, we now have burn bags, we now have gloves and different things and procedures to handle these events. But what that told me was that we need additional firefighting resources on the airplane. Has there been any movement or discussion of that?
Anybody want to?
Well, I can add to that. In addition to the installed fire extinguishers, I believe there were 5 cans of club soda that helped put out the fire.
Yeah, that's kind of like the conversation about the route structure. Minimizing the route structure, that doesn't really help that much.
No.
But and I also wanted to point out that we do go to places like Prudhoe Bay, Barrow, and Nome, which are all beautiful oceanfront beach resorts. So I just wanted to point that out, please.
And that was an event that did prompt the bags. Absolutely.
Scott, can I address that?
No, go ahead, Mark.
Actually, when we developed, and with Dick and with Dwayne, especially at ICAO, when we developed some of the crew responses to in-flight, especially in the cabin events, what we focused on is having a consistent application for a fire, so taking a fire extinguisher and halon extinguisher and knocking down the flames. But then what we wanted the crew to focus on was not using the rest of the firefighting equipment, but rather non-flammable liquids, waters, sodas, anything like that. We have, I don't know about your airline, but certainly at my airline, we have lots of bottles of water on the airplane, and that's what I would rather see used, because you need large quantities of a liquid to cool the device, and not necessarily even a water fire extinguisher with a long range or a halon fire extinguisher. I don't want to put words in Dick's mouth, but we actually, my personal opinion is I'm not in much favor of the bags, to be honest with you, because I think that you have 2 cases. Well, if every passenger put their devices in a bag before they got on and left them there, that'd be great. Then if they caught on fire, it'd be fine. But in my opinion, either the device is on fire or smoking or hot and you need to cool it down, and then you need to be leaving it where it is, not moving it and putting water on it, or the event is over, and then I don't care what you do with it. So that's my perspective on it. I would rather have you fight the fire initially with the extinguisher and then follow up with a lot of cooling agent.
Just a quick follow-up from what Mark said. The FAA's position is that you knock any flames down with halon and you put copious amounts of water. Number 1, you want to cool the batteries. Number 2, it stops a lot of the smoking, and smoke is a big product of these cells. We do not recommend you put them into a bag unless they've been cooled with water and very well cooled, because the gas can explode inside the bag and tear the bag apart. We've had that in tests. and there are other consequences. So we recommend extinguishing flames, cooling with a liquid, a non-flammable liquid, water, club soda, whatever you have, and getting the device cool. And then if you want to put it in a bag or in a sink or in something that contains water, fine. But that would be the FAA's recommendation.
All right. Thank you very much, Dick, Dwayne, Mike, and Mark. I think it's been an interesting discussion. I'm sorry, Rich. If you have a question, you're welcome to come up and try and track down the person it's for.
He is always so concise. We can take his quick question. We're okay on time. Concise.
Okay, I'm not going to be responsible for the late lunch. Go ahead, Rich.
All right, as you guys are aware, and thank you very much for your time and presence today, but as you guys are aware, there are no requirements for fire suppression on the aircraft compartment. And although you've been talking about passenger, the lithium battery hazard, the fire hazard that exists with it, gets funneled to cargo aircraft. So we end up hearing, thousands upon thousands of lithium metal batteries on our flights. So just want to pitch it to you guys to maybe talk about that risk, what you think that risk looks like, and what we need to do about it going forward.
Right.
I'm not sure.
See, that was an easy question, real succinct, short answer, I'm sure.
I think that's a great topic for another forum.
Yeah.
We're going to have to discuss that later.
All right, I'm going to track this panel down, and we'll have a discussion.
Scott, thank you very much, and thank you, panelists, for a great discussion. This is some of the greatest minds in the business talking about this. So thank you very much.